Hello everyone, welcome to today's presentation. I'm excited to share with you our topic, winds, storms, and cyclones. On this first slide, you'll see the title and subtitle. Over the next few minutes, we'll explore what causes these weather phenomena, how they impact us, and what we can do to stay safe. Let's get started. Welcome to the contents of today's presentation. We will be exploring various fascinating aspects of weather phenomena, starting with the introduction. Then, we'll delve into how air expands when heated, which is a fundamental concept in understanding weather changes. Next, we'll look at thunderstorms and cyclones, examining how these powerful storms develop and impact our environment. We'll also discuss wind, including how it's generated and its significance in weather patterns. Moving forward, we'll explore the concept of hot air rising up, which ties into the formation of many weather systems. We'll cover precautions during thunderstorms to keep ourselves safe, and then examine regions near the equator where cyclones tend to form, highlighting the geographical factors involved. Additionally, we'll look at the destruction caused by cyclones and how people can prepare and respond effectively. The presentation will also cover other safety measures for those living in cyclone-prone areas. Furthermore, we'll understand how wind currents are generated due to uneven heating on the Earth, and how high-speed winds are accompanied by reduced air pressure, which is crucial for understanding storm dynamics. We'll explore the structure of a cyclone and how a thunderstorm can develop into a cyclone, emphasizing the importance of early detection. We'll touch on tornadoes, their characteristics, and how they differ from cyclones. The role of advanced technology in predicting and managing these weather phenomena will be highlighted as well. Finally, we'll discuss effective safety measures, the importance of staying prepared, and some homework to reinforce what we've learned today. Throughout this presentation, I'll be connecting these points to give you a comprehensive understanding of these powerful natural events and how we can stay safe while respecting their force. On October 18, 1999, Orissa was struck by a powerful cyclone with wind speeds reaching 200 kilometers per hour. This storm caused massive destruction, smashing about 45,000 houses and leaving around 700,000 people homeless. Just 11 days later, on October 29th, another cyclone hit the same region, this time even more intense, with winds of 260 kilometers per hour. This second cyclone brought with it water waves approximately 9 meters high, leading to a tragic loss of thousands of lives. The destruction wasn't just limited to lives. Property worth crores of rupees was destroyed, and the cyclone severely impacted agriculture, transportation, communication, and electricity supply. These events highlight just how devastating cyclones can be. But you might be wondering, what exactly are cyclones? How do they form? And why are they so destructive? In this chapter, we'll explore those questions to better understand these powerful natural phenomena and their impact on our lives. Let's start by talking about wind, which is a key component when we discuss air activity. Wind is simply the movement of air from one place to another. Before we dive deeper into what makes up a cyclone, it's important to get comfortable with this idea. When we say wind, we're referring to the air that's always moving around us, sometimes gently, sometimes very strongly. Understanding wind helps us grasp how air behaves on a larger scale, especially during weather phenomena like cyclones. So, as we move forward, keep in mind that wind is the fundamental activity involving air that shapes many weather patterns. Let's try an interesting experiment to understand how air exerts pressure. Take a tin can with a lid and fill it about halfway with water. Now, carefully heat the can over a candle flame until the water starts boiling. Keep it boiling for a few minutes to ensure there's a lot of steam inside. Once that's done, blow out the candle and immediately put the lid tightly on the hot can. Be very careful here because the can will be hot. Place the can in a shallow vessel or basin filled with cold water and watch what happens. The can suddenly gets crushed or deformed. Can you guess why that happens? Well, it's because when we heated the can, the air inside expanded and pushed out. Once we sealed it and then cooled it rapidly, the air inside contracted, creating a low pressure inside compared to the outside air. The external air pressure then crushes the can inward. If you don't have a tin can, you can try a similar experiment with a soft plastic bottle. Fill it with hot water empty it quickly, and cap it tightly. Then, place it under running water and observe what happens. This demonstrates how air pressure outside the container can exert a force that changes its shape, proving that air is exerting pressure all around us. This experiment connects directly to the overall theme of understanding how air influences our environment and objects around us. Now, let's look at how high-speed winds are actually connected to air pressure. I want you to try a simple activity. Crumple a small piece of paper into a ball, smaller than the mouth of an empty bottle. Then, hold the bottle on its side and place the paper ball just inside the opening. Now, try blowing on the paper ball to push it into the bottle. You can even try this with bottles of different sizes to see if it makes a difference. What you'll notice is that when you blow harder, the paper ball moves more easily into the bottle. This demonstrates that when wind speed increases, air pressure decreases. Air naturally moves from areas of higher pressure to areas of lower pressure. The bigger the difference in pressure, the faster the air flows from high to low. This activity helps us understand a key point. High-speed winds are always accompanied by reduced air pressure. Recognizing this connection is essential because it explains why weather phenomena like storms and tornadoes form. The faster the wind, the lower the pressure in that region. This concept links directly to our overall theme, understanding how air movement and pressure differences drive weather patterns and natural phenomena. Now let's look at how air expands when heated. I have here a boiling tube with a balloon stretched tightly over its neck, secured with tape to make sure it fits snugly. First, I'll pour some hot water into this beaker. Then, I'll carefully insert the boiling tube into the hot water, making sure the balloon stays on top. What we want to observe is how the shape of the balloon changes over the next 2 to 3 minutes. When the air inside the tube heats up, it expands, causing the balloon to inflate slightly. Once we've seen this effect, I'll remove the tube and let it cool down to room temperature. To see the reverse, I'll then place the same tube with the balloon into a beaker of ice-cold water for another 2 to 3 minutes. As the air cools, it contracts, and you'll notice the balloon deflating or shrinking. This simple experiment clearly demonstrates that air expands when heated and contracts when cooled, which is a fundamental concept in understanding thermal expansion. It connects directly to how temperature changes affect gases and is a key point in our overall discussion of thermal properties. Let's look at this simple experiment to understand why hot air rises. Take 2 paper bags or cups of the same size and hang them upside down from a stick, balancing them carefully. Then, tie a piece of thread in the middle of the stick and hold it like a balance. Now, place a burning candle below one of the bags. As you observe, you'll notice that the bag above the candle starts to move upward. That's because warm air rises. When air is heated, it expands and takes up more space. This makes it lighter than the cooler, surrounding air. So warm air becomes less dense and rises, just like smoke going up from a fire. This concept explains many natural phenomena. For example, in the environment, warm air rises at certain places, causing local air pressure to drop. Cold air from nearby areas then rushes in to fill the space left behind. Understanding this process helps us see how temperature differences drive air movement and influence weather patterns. It's a simple but powerful example of how heat causes air to move and shape our environment. Let's explore how wind currents are generated due to uneven heating on Earth. First, consider the regions near the equator, which receive the maximum heat from the sun. This intense heating warms the air, causing it to rise. As the warm air ascends, cooler air from the regions around 0 to 30 degrees latitude on either side of the equator moves in to replace it. These winds generally blow from the north and south toward the equator, creating a circulation pattern. Now, moving toward the poles, the air is colder than at about 60 degrees latitude. Here, the warm air rises, and colder polar winds rush in to take its place. This process sets up a continuous circulation of winds from the poles toward the warmer latitudes. Next, let's look at how land and water heating differ, especially during summer. Land heats up faster than water, so near the equator, the land's temperature often exceeds that of the oceans. This heated land causes the air above it to rise, creating a low-pressure area. As a result, winds flow from the oceans toward the land. These are what we call monsoon winds. So, in summary, uneven heating, both between the equator and poles and between land and water, drives the wind patterns we experience globally. The word monsoon comes from the Arabic word mawsum, which means season. It's fascinating how language connects to the natural phenomena we experience. During winter, something interesting happens with the wind. Its direction actually reverses, flowing from the land out to the ocean. This reversal is a key part of the water cycle, which is essential for life on Earth. Now, when the winds blow from the oceans, they carry moisture, water vapor, toward the land. As this moist air rises and cools, it forms clouds that bring us rain. And this rain is not just a weather pattern. It's a vital part of our agriculture and our daily lives. Clouds bring rain, and in turn, they bring happiness, especially to farmers who rely heavily on monsoon rains for their crops. So, in essence, the monsoon is a natural cycle driven by wind patterns, crucial for water supply and farming. It's amazing how a simple change in wind direction can have such a big impact on our environment and our livelihoods. Let's talk about thunderstorms and cyclones, two natural phenomena that can sometimes turn into disasters and threaten all forms of life. Starting with thunderstorms, they often develop in hot, humid tropical areas like India, where the weather is just right for their formation. When temperatures rise significantly, they cause strong upward winds that carry water droplets high into the atmosphere. These droplets cool and freeze at higher altitudes before falling back down as rain. Now, the rapid movement of these falling water droplets, combined with the rising warm air, creates a lot of electrical activity, what we see as lightning, and the sound we hear as thunder. This entire process results in what we call a thunderstorm. Understanding these natural processes helps us better appreciate the power of nature and the importance of preparedness in such weather events. When a storm comes with lightning, it's crucial to know how to stay safe. First, never take shelter under an isolated tree, as lightning tends to strike tall objects. If you're in a forest, look for a small tree or a group of trees that are lower and less isolated. Remember, a car or a bus is a much safer place to seek shelter because the metal frame helps protect you from lightning. It's also important not to lie flat on the ground, as this puts you at risk of a lightning strike or ground current. If you're in water, the safest move is to get out immediately and head inside a building. Be cautious with umbrellas. Avoid those with metallic ends, since metal can conduct electricity. Also, do not sit near windows or under structures like garages, storage sheds, or metal sheds during a storm, as these are not safe shelter options. By understanding and applying these precautions, we can reduce the risk of injury during thunderstorms and ensure our safety, which is a key part of staying prepared and safe in all weather conditions. Let's talk about how a thunderstorm transforms into a cyclone. First, we know that water needs heat to change from liquid to vapor. Before clouds form, water absorbs heat from the surrounding atmosphere and turns into vapor. When this vapor cools down and turns back into raindrops, that process releases heat back into the air. This released heat warms the nearby air, causing it to rise. As the air rises, the pressure drops, and more air rushes towards the center of the storm. This cycle keeps repeating, fueling the storm's growth. Eventually, these processes lead to the formation of a low-pressure system with very high-speed winds spiraling around it. That's what we call a cyclone. Factors such as wind speed, wind direction, temperature, and humidity all play crucial roles in developing these powerful weather systems. Understanding this cycle helps us grasp how thunderstorms can evolve into such intense cyclones, connecting to the bigger picture of weather patterns and climate dynamics. Let's take a closer look at the structure of a cyclone. At the very center, we have what's called the eye of the storm. This area is actually calm, surprisingly so, and it's free of clouds. The eye is typically about 10 to 15 kilometers high and can range in diameter from 10 to 30 kilometers. Imagine a large, clear, relatively peaceful spot in the middle of all the chaos around it. Surrounding this calm eye is a ring of intense activity, known as the eye wall. This region extends roughly 150 kilometers outward from the eye and is where the most powerful winds and heaviest rains are found. Wind speeds here can reach between 150 and 250 kilometers per hour, making it extremely dangerous. As you move away from this core, the wind gradually slows down, and the clouds become less dense. The entire process of how a cyclone forms is quite complex, involving many atmospheric factors coming together. Understanding this structure helps us better grasp how cyclones develop and why they can be so destructive. Cyclones can be incredibly destructive natural phenomena. Even if a storm is hundreds of kilometers away, its strong winds can push water towards the shore, serving as one of the first signs that a cyclone is approaching. These powerful winds generate large waves that are so forceful, they can overwhelm anyone trying to resist them. At the center of the cyclone, the low pressure causes the water surface to rise dramatically. This rising water, which can reach heights of about 3 to 12 meters, looks like a massive water wall moving inland. When this happens, seawater spills into low-lying coastal areas, often leading to severe loss of life and property. It also impacts the land by reducing soil fertility, which can affect agriculture. Additionally, heavy rainfall during a cyclone can lead to flooding that worsens existing conditions. The high-speed winds don't just push water around. They can also damage homes, communication systems like telephones, trees, and other infrastructure. All these effects combined can cause tremendous tragedy and loss. Understanding these destructive forces underscores the importance of preparedness and early warning systems in cyclone-prone regions. Let's take a closer look at the regions near the equator where cyclones tend to form. It's interesting to note that a cyclone is known by different names depending on where you are in the world. For example, in the American continent, we call it a hurricane. But if you go to the Philippines or Japan, you'll hear it called a typhoon. These names might be different, but they all refer to the same powerful storm system. Recognizing these regional differences helps us better understand how these storms are perceived and prepared for across the globe. This also ties into the overall theme of how geography influences weather phenomena. Today, I will talk about tornadoes, which are quite rare in our country. A tornado is usually a dark, funnel-shaped cloud that extends from the sky down to the ground. Most tornadoes we see tend to be weak, but it's important to remember that a really violent tornado can reach speeds of about 300 kilometers per hour. These powerful storms can sometimes form within cyclones, which are large-scale storm systems. Now, when we look at India's coastline, it's particularly vulnerable to cyclones, especially along the east coast. This area faces higher risks both in terms of how often cyclones occur and how intense they can be. On the other hand, the west coast of India is less prone to such cyclonic storms, making it relatively safer from these kinds of severe weather events. Understanding these differences helps us better prepare for natural disasters and highlights the importance of regional weather awareness. Let's talk about some effective safety measures that are crucial during cyclone events. First, having a reliable cyclone forecast and warning service is absolutely vital. This allows us to anticipate storms early and prepare accordingly. Next, rapid communication plays a key role. It's essential that warnings reach government agencies, ports, fishermen, ships, and the general public quickly and clearly. This way, everyone has the information they need to act swiftly and stay safe. Another important measure is the construction of cyclone shelters in areas that are most vulnerable. These shelters provide a safe haven for people during severe storms. Additionally, we need to have solid administrative arrangements in place to move people quickly and efficiently to these safer locations if a cyclone strikes. All these measures work together to protect lives and minimize damage. They are a critical part of our overall approach to disaster management and safety during cyclone seasons. When we hear warnings from the meteorological department through TV, radio, or newspapers, it's really important that we don't ignore them. These warnings are there to keep us safe and to prepare us for what's coming. Next, we should make the necessary arrangements to protect our household goods, our domestic animals, and our vehicles. That means moving them to safer, higher ground if possible. We also need to be cautious while traveling. Avoid driving on roads that are flooded or covered with standing water because the damage might be hidden beneath the surface, making it dangerous. And finally, it's wise to keep a list of emergency contact numbers, like police, fire brigade, and medical centers, handy and ready to use if needed. All these actions are about being proactive and staying safe, which is so crucial during such times. Remember, staying alert and prepared can make a big difference in protecting ourselves and our loved ones. Now, let's talk about some other precautions you should take if you find yourself in a cyclone-affected area. First, it's really important not to drink water that might be contaminated. Always make sure to store enough safe drinking water for emergencies, as this can be vital for your health. Next, please remember not to pressurize the rescue teams by making undue demands. They are there to help, and respecting their effort ensures everyone gets the assistance they need efficiently. Also, avoid touching wet switches or fallen power lines. They can be extremely dangerous because of the risk of electric shock. Always stay clear of such hazards and report them to authorities. It's also very helpful to cooperate and lend a hand to your neighbors and friends. During these times, community support can make a huge difference in recovery. Finally, do not go out just for fun. Going outside unnecessarily can put you at risk and hinder rescue operations. Staying safe and staying put unless absolutely necessary is the best course of action. Remember, these precautions are all about keeping yourself safe and helping the entire community recover more smoothly. These days, we are much better protected than in the past. Back in the early part of the last century, coastal residents might have had less than a day to prepare or evacuate their homes when a cyclone was approaching. That's a huge difference compared to today. Thanks to advancements in technology, especially satellites and radars, we can now monitor storms more effectively. For example, a cyclone alert or watch is now issued 48 hours before a storm is expected to hit, giving communities more time to prepare. And if a cyclone is very close, a warning is issued 24 hours in advance. This means people have crucial time to evacuate or secure their homes. You'll also notice that during a cyclone's approach, messages are broadcast every hour or even half hour, keeping everyone informed as the storm gets closer. This ongoing communication is vital for safety. It's important to highlight that many national and international organizations work together to monitor these storms and coordinate disaster response. This global cooperation is a key part of how we've improved our ability to protect lives and property from cyclone-related disasters. All of these technological advancements connect directly to the overall theme of how we're better prepared today, and how innovation continues to play a critical role in saving lives. Let's quickly review some important weather phenomena we've discussed. First, wind. It's simply the movement of air from high-pressure areas to low-pressure areas, and it plays a crucial role in shaping our climate and weather patterns. Moving on to monsoons, these are seasonal winds that bring heavy rains, especially in regions like India, and are vital for agriculture but can also cause flooding. Next, a cyclone is a large, rotating storm system characterized by low pressure at its center, with strong winds spiraling inward. To better understand it, imagine the structure of a cyclone as having an eye at the center, surrounded by the eye wall with intense thunderstorms. The diagram on the slide illustrates this clearly, showing how the wind speeds increase as you move towards the eye wall. Now, a tornado is a violently rotating column of air that extends from a thunderstorm to the ground. They are smaller in size compared to cyclones, but incredibly destructive due to their intense wind speeds. Finally, speaking about the destruction caused by cyclones, these storms can lead to significant damage, such as flooding, destruction of buildings, uprooting trees, and even loss of life. Understanding these phenomena helps us better prepare and respond to such natural events.